Hmm. Hello, audible? Hello, audible?
Yes, sir, audible.
Okay, great. Thank you. Now there was a recent question paper is there this month, August month. Uh, this one. Part A of this. Part A of this is your one from amplifier circuit. Now explain how the efficiency and regulation of transformer can be set by open circuit sources. This is also an important question. Fifth. It is from transformer. Now we come to the second, this one. Last question. It is readable. So in parallel
Yes, sir.
resonance. See here it is written at tuned circuit consisting of a coil having an inductance. That coil has an inductance and resistance of 20 ohm. Inductance is 200 microhenry and resistance is 200 ohm in parallel with a variable capacitor. Is connected, this twinned circuit is connected in series with a resistance of this across the supply of 60 volt and frequency is 1 megahertz. Calculate of value of C. So here variable capacitor is connected to resonance to give resonance. Means what is the value of C which at for which the circuit is under resonance, means it gives the resonance. Okay. Yes. Only 7 persons in the evening session. Okay. So here he said that there was a one coil, practical coil. Okay. Okay. हेलो। हाँ जी ठीक है सर, धन्यवाद है। हाँ हम लोग, हाँ आ गए हम। 1 मिनट है। हाँ उधर पैसे जमा करा दिया और हेलो ऑडिबल प्लीज, सॉरी है चलिए। So there was a coil. So that coil is a practical coil, means that has a resistance and inductor. Okay, this coil. Okay, well, means actually practical coil is there. Across this coil there is a inductor, capacitor. This form a twin circuit. But if it is a practical coil, then there is a resistance also. So this is the coil resistance. This is your inductor, coil inductor. Then this and there is a one capacitor is connected with this, parallel with this is your twin circuit. This is called twin circuit. Okay. Across this there is a one series resistance is also there. One series resistance. It has a value of 8,000 across this twin circuit. Across this, now we have apply here potential. This is 60 volt, 50 hertz. No, 50 hertz. This is the frequency is given. Operating frequency is 1 megahertz. 1 megahertz means 1 into 10 raised to power 6 hertz. Okay, please. 10 raised to power minus plus mega means 10 raised to power 6 hertz. Okay, please. This is the frequency. Now he said that calculate the this value of C. Now here this is a variable capacitor. So as I told now, either we vary the frequency or vary the capacitor to get a resonance. So he said that what is the value of C for which this circuit is resonant. This twin circuit under resonant, it gives a resonance. Okay. So see up to this now, this is your twin circuit here. This portion. Correct? Okay. Next, he has the dynamic impedance and what is the quality factor, Q factor of twin circuit. Now this capacitor is real, this coil is practical, means there is a power loss. Now I will explain this. Then he asked the current. Okay. Now here total current is under this condition, the total current is I. This current is now divided in these two parts. So this is I1, this is I2. I2 or it is IL, current through coil, and this is current through capacitor, inductor capacitor. Or either you can denote by 1 and 2. You can denote with 1 and 2, okay, branch 1 and branch 2 current, okay, like this. Okay. So there is a one derivation is required because otherwise you can directly remember the thing. See, first of all, this part A, if we calculate resonant frequency of oscillation, resonant frequency for oscillation, okay, for parallel circuit, it is 1 by 2 pi then under root 1 by LC minus R square by L square. Okay, this is the formula for parallel resonance circuit. Okay, but as compared to inductor, this value is how much it is? 200 microhenry. This is 20 ohm. Okay. Actually, we neglect this portion. If we neglect this, this is negated. Then again, this F naught equals to 1 by 2 pi. It become only under root LC, like in series circuit. Okay, this. So if you know the value of L and C, then we can calculate a frequency. Now here frequency is given, resonant frequency 1 into 10 raised to power 6. 1 into 10 raised to power 6 hertz. Okay, equals to 1 by 2 pi. What is the value of L? L is, this is the L, microhenry. So 200 into micro means 10 raised to power minus 3. Then capacitor, we not know. So it is a C. Capacitance is C, LC. Now you equate this. Now we square on both sides. If when we square this, so this become a 10 raised to power 12 because square is multiple, equals to 1 by this 2 pi is square, and this become 200 into 10 raised to power minus 3 into C. or now we C take this side, then this go this side, okay. Minus. So now C we can take this side, then therefore value of capacitor C, value of C with for which your circuit is resonant, value of C that give resonance, that gives resonance, or the resonance is occur, okay, circuit under. So this C equals to C, this C we take this side, then this go 1 by, now this minus 3 is come up, 10 raised to power 3 it become, divide by 2 into 3.14 pi is the whole square into 200 into this comes here, 10 raised to power 12. Okay, this C. Okay, now if you solve this, we get a value of C. Okay, then in next question, or you can calculate in microfarad or picofarad, okay, this value. Sorry. Next it is asked, we solve this, okay, now you come to the dynamic impedance, part B. B, dynamic impedance, Dynamic impedance means it is actually resistance, effective resistance, total resistance under resonance actually. Okay, it is your impedance of the circuit under resonance. Okay, total effective resistance at resonance. Effective impedance or resistance at resonance, that is denoted by dynamic impedance. Here we write ZD, dynamic impedance. Okay, why? Because it has also reactance, that's why it is impedance. So basically, like under resonance, your series circuit is resistance becomes equal, total impedance become to resistance, real part only. Same like in parallel resonance, this is the effective impedance. Now this value is actually dynamic impedance ZD equals to R square plus XL square divided by R, or it is, this value is L by C, R, or you can say L by CR. It is in ohm. So please you remember, this is the formula for L by CR is your dynamic impedance. As it is written in parallel resonance, comparison, this L by CR is the effective resistance, effective impedance under resonance in parallel. But in series only Z equals to R, but here it is L by CR. Then you come to the quality Q factor. Q factor. Q factor is the quality factor actually. It represents the loss to your energy stored. Now energy stored in inductor or capacitors and energy dissipated in resistance. So here for twin circuit, the energy stored in L and energy dissipated in R of the coil. Now C is a ideal capacitor, there is no power loss. Please, Q factor of a twin circuit is defined as the ratio of this Q factor. Okay. Please you write this Q factor equals to, it is defined as the ratio of energy stored to energy dissipated. Now see, this energy dissipated in R means what is the current through R? I1. So it is I1 R is I1 square R, no? Hello, this is I1 square R divided by energy. This reactance it is stored. So like in stored energy in inductor, then it is I1 square XL, but it is dissipated in I1 square R. Okay, I cancel, then it is XL by R. XL by R. Now under resonance condition, because circuit is your under resonance. So you know XL equals to omega L. Omega means resonant frequency, omega L by R. Now here we put the value of this. This will give your, now this is 2 pi F naught L by R. So this is your Q factor of twin circuit. Please you remember. Next is what is the part? Current in AC. Then we can calculate the total impedance. So up to here, the impedance is dynamic impedance of this circuit, and you calculate R1, Z1. Then this series resistance, total impedance is this plus the impedance of this. Okay, correct? Then we calculate the total current I, and then we apply the current division. Then we calculate I1, I2. Okay. Please, if we see now here, first of series resonance, parallel resonance, there is a resistance, there is an inductor of coil. Then this is the capacitor. Okay. First, this is your twin circuit, correct? No? So here suppose R, L, this is C. Okay. So in this branch, suppose it is a impedance Z. This is has a Z1 impedance. This is has a Z2. So what is the branch impedance for this? Okay, branch impedance. Please. Z1 is R plus JXL, and Z2 equals to minus J omega C. Okay, please. Now we calculate admittance. Now in parallel circuit, now we calculate admittance. Hello, please you also remember in parallel circuit, now we calculate, there is a resistance, then there is a reactance. Reactance is X. Reactance, then there is a impedance. Okay, the inverse of 1 by R, inverse of R. Inverse R, opposite of this R is conductance. Opposite of this is susceptance. Okay. Opposite of this is admittance. It is denoted by Y. Okay. This is conductance. Conductance is inverse of resistance. Reactance is inverse of susceptance. Susceptance. And this is admittance. Now these are unit ohm, ohm, ohm. This all has a opposite of ohm. Okay, please. Got it? Hello. Please you remember this. Resistance, reactance, impedance. This is resistance, reactance, impedance. So impedance Y equals to 1 by Z actually. B equals to 1 by X. G equals to conductance equals to 1 by R. Like this. Inverse, they are. Okay. So here we calculate now branch admittances. Y1 is branch 1 admittance. What is the Y1? Y1 is 1 by means 1 by Z, that is means R plus JXL 1 by this. Then Y2 equals to 1 by Z2, 1 by Z2 means minus JXC. Okay, please. Now this is multiple with complex conjugate na J by J. Okay, actually value of J na, it is a operator. What is it? J is a vector operator. Vector operator. If I suppose vector P okay, if it is multiple by the J na, it rotate in anti-clockwise direction with 90-degree angle. So it calls JP. Then if it is further multiple, then it comes J square P. Then again if it is multiple with J Q P, and this is J raised to power 4P. Now actually J equals to means iota, or it is root minus 1, under root minus 1, okay, and under root minus 1, under root minus 1. So if we put na J square means it is a minus 1 minus P. So it is opposite na, opposite vector means minus P, this is minus P, okay, it is opposite. And if it is Q, then it means minus JP, okay, this. J cube means minus JP. Again it is 4 times na, then minus 1 into minus 1. J square. This is minus 1 into minus 1. So it become a plus 1. J, okay. Okay, so this is a J operator. Okay, it represents the imaginary portion of a vector. Oh, sorry. Now you come to again here. So we can multiply this with complex conjugate of this minus JXL by minus this is minus JX. So if we multiply na this with same number, multiple and divide, then nothing change na. This value is not change. We can, but this will come. Now, hello, what did this become? This become R minus JXL by this become A plus B and A minus B. So it is R square A square minus now minus A square minus B square. B is J omega XL square. So, J square means -1, then it becomes plus XL square. Okay, please. Got it now? If you multiply, this is A plus B and A minus B. You know the trigonometric formula, A square minus B square. A plus B and A minus B. Okay? And this become a J square. J square is -1. Then it is minus, then it become a plus. Then this value becomes J by XC. Okay, right. Now total circuit admittance. Total admittance of this twin circuit, please. Total equivalent and admittance of twin circuit. What is the total admittance? It is a parallel, no? Then admittance Y equals to Y1 plus Y2. So if Y1 means R minus JXL by R square plus XL square plus J by XC, no? J by XC. Okay, please. Then we calculate. It is a admittance of the circuit total. Now we can take a LCM, no? What is the LCM is come? LCM is come R square plus XL square into XC. So see, this cancel, it become a R minus JXL. Okay, this will cancel. Okay, it is divided by this, then it is this into XC. This multiple plus. Here it is this divide, it comes J into R square plus XL square. Now we open this numerator part. So it become a R XC minus J XL XC plus this become a J R square plus J XL square. Now J part is this, hello, and this is your total is R square plus XL square into XC. Okay. So here now real part in numerator. What is the total real part in numerator? This only, na? This all three has a J portion. J means imaginary part, like Z equals to R plus JXL. So this is called imaginary portion, reactance. This is resistance, real number. This is a real. This is imaginary part. Okay. So if resistive circuit, na, then imaginary part is become 0, na, in net reactance. In RLC circuit, hello, what is the impedance? R plus J XL minus XC, na? So this part is become 0 at resonance. Okay, correct, na? In series resonance. So that condition we apply also here. See how to. Okay. So first we calculate total. Real portion is R XC. This is the here is no multiple J, no? But then in another portion you have to subtract the this has a J portion, so plus this and this. This you can take a J common, then it comes R square plus XL square, and this is minus XL XC, minus XL XC. Okay, this. Now this individually they are divide also. Now if this portion is divided by this, no, so this XC cancel here. It become R square plus XL square only. So this also remove. Okay. May I correct now? If this real number is divided by this, XC cancel only this, and here this is completely divided by R square plus XL square into XC. This is total admittance. Now, hello, admittance is, it means it is y equals to 1, it is inverse of z. Okay, so means same, like z has a two part, na, real and imaginary. Similarly, your admittance also has a two part. This is the real portion, this is imaginary portion. Imaginary. Now imaginary means this is your reactance. So for now you apply the resonance condition in twin circuit. If suppose at resonance, or under resonance, at resonance, this imaginary part is 0. Imaginary part is 0, or this that equals to 0. Imaginary part means R square plus XL square minus XL XC divided by R square plus XL square XC. This portion equals to 0, means this. It means this is multiple with 0, no? This numerator. So it is only R square plus XL square minus XL XC equals to 0, or R square plus XL square equals to XL XC, because this is negative, no? So it goes this side, then it becomes a plus. Okay. Now please, now you know XL XC. XL means omega L, and XC is 1 by omega C. Now this is at resonance condition, it means it is omega naught at resonance frequency. Okay. So this you know from here omega cancel. Okay. Equals to, this is R square plus XL square. Now this become L by C. So L by C equals to R square plus XL square. Okay, R square plus XL square. Okay, please you remember this. Okay. Now we come to the dynamic impedance. Hello, this is your total admittance. Then what is the Z? What is the impedance? Therefore, total impedance, total impedance of circuit under resonance, Z equals to 1 by Y. It means we do the inverse of this. So yeah, actually at resonance this is 0, then only this portion. So this Y equals to 1 by inverse of this. It becomes it is a Y now, that is R by R square plus XL square. Then Z equals to, okay, so this is called dynamic admittance. equals to means dynamic. Dynamic means only effective. So it is a dynamic impedance. That's why total, or you can write dynamic. Therefore, this is dynamic. Dynamic impedance equals to dynamic admittance 1 by, then it is R square plus XL square, inverse of this, divided by R. Now R square XL square is what? Hello. Now from this we get R square plus XL square is L by C. So now we can put here L by C. L by C by R, or it is L by CR. Okay, this ohm. Now you get, hello, how it come dynamic impedance L by CR? Hello, you get how it comes? As we write in initial, hello, correct we write here for this circuit, okay. B is dynamic impedance, as I told this is L by CR. So how it is come? If they change circuit, you can calculate by this method, okay. This is apply this is L by CR is this, okay, L by C, then we put here. Got it? Dynamic impedance. For now to calculate dynamic impedance we require a value. Yeah.
सर इसमें जो एक हमने किया था ना, मल्टीप्लाई किया था स्टार्टिंग में R माइनस XJ वाला, जो आपने ग्राफ बना के बताया था, उसको एक बार एक्सप्लेन कर.
Let's conjugate ना.
ये जो इमेजिन, हाँ सर ये पार्ट, ये वाला नहीं पता चला बस.
देखिए एक्चुअली हम जब वेक्टर में जब कैलकुलेशन करते हैं तो हम चाहते हैं कि आपका डिनोमिनेटर मतलब इजी हो जाए. तो एक्चुअली चाहते हैं जो न्यूमरेटर में आ जाए ये पार्ट. तो ये डाउन था तो हमने इसको कॉम्प्लेक्स कंजुगेट से मल्टीपल कर दिया. कॉम्प्लेक्स कंजुगेट मीन इफ इट इज प्लस ये इमेजिनरी पार्ट, तो वी टेक ए माइनस पार्ट. अभी सपोज वी हैव ए सम वैल्यू x. Now this x is multiple same numbers or divide by same, then nothing change, no? So if we multiple this 1 by, actually first में यही था, इतना पार्ट है. Okay.
ठीक है सर, उसको सिर्फ वो कैलकुलेशन के लिए हमने किया, ताकि वो चेंज कुछ नहीं होगा. R माइनस XJ के साथ कर दिया, XL के साथ मल्टीप्लाई ऊपर और नीचे दोनों में.
तो हम इसमें कॉम्प्लेक्स कंजुगेट से भी मल्टीपल एंड डिवाइड विद सेम नंबर, लाइक ऑफ कॉम्प्लेक्स कंजुगेट ऑफ दिस R minus JXL. So here now you can apply the your this one.
बाकी क्लियर हो गया था सर, बस यही था कि ये क्यों किया था हमने ना, पी डाउट था
के लिए.
जी, बाकी कैलकुलेशन थी वो हो गया था.
तो ये डायनेमिक इम्पीडेंस के लिए आ गया. ओके, नाउ वी फर्दर डू. तो ये दिस इज हाउ द डायनेमिक इम्पीडेंस इज कम. नाउ वी कैलकुलेट फॉर रेजोनेंस फ्रीक्वेंसी.
सर ये जो हमने इम्पीडेंस कैलकुलेट करने के लिए उसको पहले एडमिटेंस में कन्वर्ट किया, फिर इम्पीडेंस पे कन्वर्ट किया, ऐसा क्यों सिर्फ इम्पीडेंस में कैलकुलेट नहीं कर सकते थे क्या?
एक्चुअली पैरेलल सर्किट आपके एडमिटेंस के फॉर्म में जल्दी सोल्व होते हैं पैरेलल, क्योंकि पैरेलल सर्किट में इट इज व्हेन यू नॉर्मली सोल्व द पैरेलल सर्किट इफ them ask current, then we convert into admittance.
ओके, मींस अगर पैरेलल सर्किट आएगा तो हमें उसको एडमिटेंस में करके करने से जल्दी हो जाएगा.
हो जाता है, जल्दी होता है.
ओके,
इसके लिए हम लोग उसको एडमिटेंस में कन्वर्ट कर लेते हैं. लेकिन वो बाद में क्या पूछ रहा था हमसे, इम्पीडेंस पूछ रहा है, तो हम उसका अपोजिट कर देंगे. ओके, दैट्स व्हाई. नाउ दिस इज द कंडीशन फॉर रेजोनेंस. Now if we continue this, Okay, now we continue this. Okay, now it comes L by C. Now this R is come to this side, R square equals to XL square. Now this is at resonance, no? At resonance condition. Now XL square equals to L by C, okay, minus R square. XL means omega naught L square. Okay, XL का ये all square है. Okay, XL square means omega L. XL square means omega square L square. Okay, then L by C minus R square. So now if we take a omega naught square, then it is L by C is multiple, na? Here it is divide. So if it is divided by L square means it comes 1 by LC, because one power is removed. Minus this become R square L square. Okay. So this is your resonant frequency. Okay. Now, therefore, your resonant frequency is under root of this 1 by LC minus R square by L square. So this is the but it is in radian per second. Okay. Now if we calculate in Hertz cycle per second, then omega naught means 2 pi f naught equals to this. Same. Or f naught equals to, it is 1 by 2 pi then under root 1 by LC minus R square by L square. This is the complete formula. But now, actually here this values is also given, na, R, L. You can put this all the values to calculate f naught. Now f naught is given. They are asking the value of C. Correct, na? Value of C for which the circuit is resonant. Now, for simplification, this ratio is R square by L square. This portion is neglected. Because circuit coil, this coil has a low resistance as compared to inductance. R square by L square is very low. It is less than. Okay. Therefore, we neglect this. It is negligible value. Okay, please. So what it get will finally, again, if it is neglect, then 1 by 2 pi under root LC. This much of hertz. Okay. Got it? This is the derivation. Now dynamic impedance I explain. Frequency of resonance we explain. Q factor we explain. Now if we do the solution of this question, please. Okay. So first of all, we calculate a value of C. Then we can calculate a dynamic impedance Q factor. The value of C we already know this. Please you solve this. So here this 2 and 1 we take from here. 12 we take this way. Okay. This 2 also cancel na this. So it become only. Now we solve this. Please just a minute. Now it comes 2 into 3.14 square of that into 200 into 2 only we can say. This much is the 78 2 inverse into 10 only. My dear, we get a value is 0.126778 into 10 raised to power minus 12 because this 12 is go for this. Okay, so please for microfarad now you know milli means millifarad. If we write then it is 10 raised to power minus 3. Microfarad it is 10 raised to power minus 6. Then other is for picofarad. What is the power? Hello, 10 raised to power 9. Correct na? Pico is 10 raised to power 9 or 12. What? 9 को क्या बोलते हैं?
Yes, sir.
Pico na is 9. So now it goes 1, 2, 3. Because 3 if we remove here, no pico 4. यहाँ से और यार होगा अगर तो ये और बढ़ेगा ना पावर माइनस नहीं माइनस प्लस में बढ़ेगा. यहाँ से रिमूव करते जाएंगे. Actually, questions are lengthy starting में and their explanation is required. Otherwise, if suppose they change value and numerical, then it is tough na to how to solve. So that's why it is required to understand the question. Okay. Yes. Millifarad na. Yes. Pico. तो wrong value आई है हमारी. ट्वेल्व इज अच्छा ये भी तो था. सॉरी ओ सॉरी ये नो मिली नहीं था ना. इट इज हैन माइक्रो. हेलो प्लीज वी डू मिस्टेक. इट इज ए not millihenry, it is microhenry. So it means it is 10 raised to power minus 6 here. What mistake you know? This only. It is 6. Got it? It is minus 6. Minus 6. Here power is minus 6. 10 raised to. Then it we take up na. It is plus 6 then. Okay. So now plus 6. It means to make it now this is removed. Now it comes here. Your decimal is point is come here. Okay. And 12 picofarad means not 9. It is It is 12. Pico means 12 actually. Please you remember. Picofarad means 10 raised to power minus 12. So what is your capacitance value that give the resonance? Picofarad or this much farad. Okay, please. Okay, now you calculate dynamic impedance. So this is part A. Part B. Now you know the value of L. Hello, what is the value of L? 200 into 10 raised to power minus 6 Henry. You put in Henry. You put C in capacitance value. Okay, that is 126 point. How much it is? 126.78 10 raised to power 12. 78 into 10 raised to power minus 12. Minus 12 and R is 20 ohm, na? Twinned circuit resistance. These are not, no? This series resistance is not. Only the circuit, the twinned circuit, na? Their coil resistance 20. So here it is 20 ohm. When we you solve this, please. So solve this goes up, na? Then you get this 20 is 20 cancels, only 10 we get here. Then here this 12 is removed. Then it comes 10 into 10 raised to power 6 plus, na? Divide by this only 126.78. How much it comes? Hello? Yes, please. So 1 into 1, 2, 3 divide by 0.78. Six 0.79. 788. This much of it is in what? Ohm. Okay, dynamic impedance. Hello, so what is the value of dynamic impedance? Dynamic impedance means this much ohm. 78970 200 okay, so this is your dynamic, this much. Now you calculate, hello, what we calculate then? Q factor, please. What is the Q factor? This, na? This is the here. Hello, please you put here na value. What is 2 into 3.14 into F naught is what is the frequency? Frequency is given na 1 megahertz, 6 hertz into L. What is the value of L? 200 into 10 raised to power minus 6. So this 6 cancel. divide by R. What is the value of R? R is here 20 ohm. This 20 cancel, 10 only. Now 10 into this. Hello? 2 into 3.14 into 10. 62.8. 62.8. This is the ratio of Q factor. Okay. Okay. Q factor is this. Now all solution is there. Completed. No? We have. Okay. Now branch current you come. Huh? Hello. Can we keep the solve current go? Okay. You know what is the effective resistance or impedance of twin circuit under resonance? You know now here to here this portion impedance. That is dynamic impedance. Okay, ZT. Plus this resistance, that will give the total resistance or impedance of circuit under resonance condition. When this circuit, twin circuit is under resonance. Okay. Because 8,000, na, this is ohm is 8,000 ohm. Okay. Now please see, this portion is 0, then only this much is the impedance of circuit under resonance. And this dynamic impedance we calculated. Where the value? Dynamic impedance is this much ohm. Now please, again we have to draw here. See, your total is, there is a one resistance, then there is a this resistance of this, then here is a capacitor. Okay. Now if you know the voltage and frequency. Now we know R is 20 ohm, L is 200 microfarad, and C we have also calculated, that is 126.78 picofarad. This at this point. Now total current is flow start from here, this and this series resistance is 8,000 ohm. Okay. After this now, this divide here and here. This is I1, I2. Okay. Hello. Now you know up to this point, total impedance of circuit is effective impedance. Hello.
Yes, sir. Can you explain this? After this energy stored, divided energy dispatch. This you put in response.
See, this is the effective impedance of this portion. Now this is also series resistance. So here
सर
we
आपने
apply.
ये वाला ये जो ऊपर है ना, ये आपने क्या किया है? मेरा कॉल डिस्कनेक्ट हो गया था नेटवर्क इशू.
Which one?
So
Here.
this energy stored after. Yes, sir.
Stored by the energy dissipated. तो storage inductor में stored होता है, that is I square XL. It is dissipated I square L. Then I square I1 square cancel. XL by R. Then omega L by R. Now omega naught you know 2 pi F naught. That only.
सर वैसे कैपेसिटर भी एनर्जी स्टोर करता, तो हमने एक्सएल ही क्यों लिया, एक्ससी क्यों नहीं लिया?
वो क्या है, कैपेसिटर आपका आइडियल है, लॉस कहाँ हो रहा है, ओनली इंडक्टर में। तो हम इंडक्टर के पावर स्टोर्ड एंड इंडक्टर एनर्जी डिसिपेटेड वी कैन टेक। ओके
ओके सर, क्लियर।
नाउ total this circuit, not tuned circuit, total circuit resistance, this circuit impedance, actually it is not impedance, it is a resistance, because only the resistance is there na effect. This is also active portion of resistance. So what is this? It is 8000 means RS plus Z dynamic impedance, 10,000 plus what is the total effective is 78876.79. How much ohm it is? 8000 plus 78876.79. It comes 86876.79 ohm. Therefore I1, therefore source current, source means total है, और main current है, I equals to your total source voltage by total impedance, effective impedance, this total circuit impedance है Z. If this is 60 by Z means 86876.79 to 60. My dear, this become a 6.9063 into 10 raised to power minus 4 ampere, or it is we can say na minus 4 means milli, or we can write it is 0.69 milliampere, you can say. Okay, so what is the total current? 0.69 milliampere. Okay, I. Now this I is here. Now it is divided in I1, I2. Now please you calculate Z1, Z2 in that condition. Hello, what is your Z1? What is your Z2? Hello, this Z1 is, first you calculate XL. XL is omega L, under resonance, resonance frequency. So it is 2 pi f naught L. So what is this? 2 into 3.14 into what is the frequency? 1 into 10 raised to power minus 6 megahertz, no? 1 megahertz into L is 200 micro means 10 raised to power minus 6 micro. Mega means plus, sorry, this is plus. So this is plus. So my dear, this minus and this plus is cancelled. Now what is the XL is come? 2 into 3.14 into 200. It comes 1256 ohm. Then here it comes, what is the Z will come? Now Z is R, you know it is Z1 equals to R plus JXL, or it is R square plus XL square. What is your Z1? Please. R is 20 square plus XL is 1256 square root. Hello. Root. Yeah, it is same like there nothing much difference. 16 ohm. 5616 ohm. Okay, this one. What is Z2? Z2 only C, na? So it is XL. Okay, sorry, XC only. Okay, or it is 1 by omega C, or it is 1 by 2 pi F naught. F naught is C. Put the values. 2 into 3.14 into F naught is 1 into 10 raised to power 6. C is what is the value of capacitance? Picofarad, na? How much? 126.78, na? Into 10 raised to power minus 12. Okay, so here 6 is cancelled. 6 come up, it comes 6. Then it comes here 10 raised to power 6 by 2 into 3.14 into 126.78. Correct or not? Then what is the value? No. This is your 1255.99. Means you can say it is 1256 ohm. Actually, na, it is same like or it is easily because XL equals to XC, na. So this reactance and this reactance are same. So this is we get na 156 ohm. Okay. So please Z1, Z2 you know. Z1, Z2 you know. Almost same. Now you apply the current division. Hello. Now I will show you the current division. If suppose there is a two circuit, two resistance R1 or impedance R2 or Z1, Z2 जो भी है, okay. Suppose this is the total current here. This is R1 or okay, this is R2. Now this is the total current. Now this current is divided here in two parts, na? I1, I2. What is the I1? I1 equals to, it is opposite like R2 by R1 plus R2. Okay, into total current I. Same like I2 equals to R1 by R1 plus R2 into total current. Okay, so here we put a impedance Z1, Z2. They are almost same, na? 1256, 1250. That's the current is also same. Okay, in both. So this current is divided. Now we can write na I1 and I2. I1 equals to Z2 by Z1 plus Z2 into current I. So what is the Z2? Z2 is 1256 divided by total is both are same value, na? 1 point, only the difference is 1.9, na? 1.9 only. Sorry, 1.6. We can take it is also, we can write, na? This is also 5.6. Both are same like that. Hello, this is, it is double, na? So it is half actually. The current will be half. Okay. Into total is 0.69 na? Milliampere. Then please, it is half of just na, it is 1 raised by 2 na. It is 1 by 2 into 0.69. 0.69 divided by 2. Sorry. 43. 43. 54. करंट डिवाइड कर सकते हैं. ओके. वही बात टाइम आना चाहिए. ये जस्ट मिनट है. ये सी रह जाएगा ना -6. यहाँ पे कुछ गलत किया है क्या हमने एक्सी की वैल्यू में. ओमेगा सी देन टू इंटू पिकोफैराड. क्यों नहीं आएगा. या फिर वी कैन यूज अनदर मेथड. सी व्हाट. ये भी देखिए गलत किया होता है. करंट डिवीजन इज आल्सो सेम. 43 तो आ रहा है सेम डिवाइड हो रहा है. ओके इट इज हाफ ना. 69 का हाफ हो है 34 आना चाहिए मिलियन. हाँ 34 आएगा. करेक्ट तो है. ओके तो इट इज वेयर वी राइट दिस करंट विच इज I1 I2 here ना. हाँ तो it comes सॉरी मैं रॉन्ग आया, -4 ना, मिली एक पॉइंट यहाँ आ जाएगा ना, ये माइनस, it comes point, okay, milliampere. Then here it comes half of this, no, it is double, then it means it is 0.345 milliampere. Same like I2 also, 0.345 milliampere, almost, please. Okay, because both are equal impedance, they are equal na, mostly Z1 Z2, Z1 and Z2 are equal almost. Okay, got it? So current divide equally in branch 1 and 2. Okay, okay, rest questions we see tomorrow morning. Please, now the questions are easy. Other circuit means the fundamental questions are easy. You can try your own, like Kirchhoff's law, and this you can apply. Okay, already we learn a lot of things in this. Okay, here, hello, audible. See, these questions we are easily solved. Like this also. A motor starter question is also, it is asked in last exam paper. This battery question was also asked. These things we solve tomorrow. Okay, we can complete this. Okay, please, इसमें क्या है, fundamental explanation में there is a time consuming. Okay,
Yes, sir.
okay, good night. Continue tomorrow. Please.
Good night, sir.
भी कैंडिडेट बहुत कम ज्वाइन